So you want to keep in mind that cations have a positive charge and an anion has a negative charge. These are the two types of ions that we're going to need in order to make an ionic compound. So the basic rule that you need to remember is that the charge of the cation, which in this case happens to be the positive 2, this becomes the subscript on the anion. And what that looks like is something like this. This charge becomes the subscript. Then we have the component of vice versa. So what that means is that the charge of now the anion, which is a -1, now becomes the subscript of the cation, and that will look something like this. So as an intermediate, we sort of have calcium now with a -1 as a subscript, and then we have chlorine, which now has a +2 as a subscript. But of course this looks a little bit awkward, so there's a few things we need to keep in mind to clean this up. So obviously we don't want to leave the formula looking like this, so there's a few things that we can do to change it. One of the items that we can do is that we can eliminate the negative and positive signs. So now we're left with Ca1Cl2. Another item that we can do that is not necessary in this formula is we can eliminate the number 1 when it's a subscript. You don't need to write the number 1 as a subscript. What we're left with then is a calcium, and again we're not going to write the 1, and a chlorine, and we do write the 2. So our new formula is CaCl2, and you can see that this is much cleaner and much less cluttered than the previous version. Let's take a look at another example. Let's take a look at the compound that would form between potassium, which is a +1, and how about oxygen, which is a -2. If we apply the crossover rule, +1 becomes a subscript, the -2 becomes a subscript. Again, we don't want to write the +1, we don't need to write the 1, so we're left with K2O, and that would be the final formula. Another option that you might have is if you have something like a calcium +2 and an oxygen -2. Now, before we do the crossover rule, we want to recognize that the positive and -2, we actually can reduce them. A ratio of 2 to 2 becomes a ratio of 1 to 1. So you're allowed to reduce before you cross over. And what we have then is that the 1 becomes a subscript, and this one becomes a subscript. But again, we don't have to write the number 1, so we're simply left with CaO. This is the correct formula, not Ca2O2. I think it's best to reduce your charges before you do the crossover. That will eliminate some problems later. The final item that I'd like to show you is when to use parentheses in your formula. You want to use parentheses when you have a polyatomic ion, and if you remember our abbreviation, our P is PAI, and a polyatomic ion would be something that has a combination of different elements in it, for example like this, and this is from the list that I gave you to memorize. So let's take a look at an example of what that might look like. If I take, let's say, magnesium, which is not polyatomic, but it does form a positive charge, and let's say that I combine this, how about with our phosphate, which is a PO4 -3. We still apply the crossover rule, so we take the charge and we make it a subscript. But there's a problem. If this number is greater than 1, you need to use parentheses. 2 happens to be greater than 1, so we're going to put parentheses around the polyatomic ion. We also then want to take the -3 for the crossover rule, and that will leave us with Mg. We don't write the negative for the 3, we simply write 3. We need parentheses around the PO4, we keep the PO4 as a group, but then on the outside of parentheses, we put a 2. It would look really strange if we didn't have the parentheses, because then we would have PO42. And that looks a little bit odd.